Hi, I want to talk to you about signal to noise ratio. I want you to open the textbook. Hopefully you've downloaded it from Canvas, downloaded it as a PDF file, and you're looking at it using Adobe Reader or something similar. This will be better than looking at it in Canvas. So if we open the book and go to chapter 5, here on the left-hand side, chapter 5, and make our way down chapter 5 to section 5.1.3, signal to noise ratio. I want you to read this short section, but you'll see here the signal to noise ratio is the power in the signal divided by the power in the noise. It's signal to noise ratio, signal over noise. And the power in the signal is the average of the mean pixel value. The average of the square of the mean pixel value throughout the whole image. And the noise is the variance, that is the square of the standard deviation, the variance of the pixel values measured in a region which looks like it has constant gray values. Now the noise is everywhere, but so as not to confuse it with signal, with real details, we have to select a region of interest that has no details, that looks like it has constant gray values, and make the measurement there. We look on to the second paragraph. There is an equation for the signal to noise ratio. You see here, it's the mean of the square of the pixel values, that's the power in the signal, divided by the power in the noise, which is the variance within our chosen region of interest. So that's signal divided by noise, and we can express that as a ratio, or we can take 10 log of that ratio, log to the base 10, and express it in decibels. So the signal to noise ratio, either just as a ratio or change that ratio into decibels. So that's the section I want you to read very carefully. If we open image J now, and open an image from your 345 images folder, and I'll go to Lena, but you can choose any image you like. Say Lena 256, we'll make her bigger, scale her up by a factor 2 in each direction. We don't need the small one. Make a duplicate of it. And then we want to find the signal to noise ratio of this image. That is, how much power, how much real details in this image are there compared to the amount of noise, the amount of underlying rubbish that's in the image. So we have a plugin to do that, and it's just a plugin that implements that equation 5.5 from the textbook. The plugin is in chapter 5, SNR, signal to noise ratio, but before we use it, we have to select a region within the image, a region where nothing much is happening, right? Constant grays, and we want to find the variance of those grays. The variance will be the noise. So if we go to polygon selections up here, and I'm going to take this region, but you could try other regions. You could try this region, as long as you don't cross that line, or maybe you try this region. It looks fairly constant. But you want to choose a region that's fairly constant, as big a region as you can get, where nothing is happening very much, except that there's noise there, as there is everywhere. I want to make it as big as possible. and I've chosen that region of interest, and then you can go to plugins, chapter 5 plugins, signal to noise ratio, and it will give you the average pixel value 124, and it's the square of that it uses for the signal, and it tells you the standard deviation within the region of interest, and the square of that is the variance, which is the bottom line, so it's signal to noise ratio. And when it works that out from these two figures, it gets a signal to noise ratio of 523. Or if you change it to decibels, it's about 27 decibels. Now, this value depends on which region you choose. You got to choose big enough region, but there's got to be nothing, no features, nothing really happening in it. If you do it a second time or a third time, since it depends on the region, you may get slightly different values here, especially here. So this value is not that precise. But when you take the log of it and get it into decibels, you won't see much variation in this here because it's a logged value. So that's our signal to noise ratio. Remember to read that section 5.1.3 before proceeding.